Problem 15.25 involves a belt being drawn between two cylinders here. Top cylinder is A with a 4-inch radius, and the bottom cylinder is B with an 8-inch radius. It's being drawn through without slipping at a speed of 5 feet per second. So V is equal to 5 feet per second. R sub A is 4 inches, which happens to be 1/2 of R sub B. In the A part, we're asked to calculate what the angular velocity is of A and what the angular velocity is of B. We're going to consider a point A prime that's in contact with the belt and a point B prime on the bottom here that's in contact with the belt. So those 2 points would have velocities equal to the 5 feet per second. So that means that a VA prime, if we look at a point on top of the belt right there, a VA prime would be equal to omega ARA for rotation about a fixed axis, and since this axis doesn't move, that is a fixed axis then. And you can calculate omega A then to be equal to 15 radians per second. By the way the belt's being drawn through, that means that this rotation has to be in this direction right here, which is counterclockwise, and that's shown with this arrow right here. For the velocity VB prime right here, velocity that's in this direction, first of all, note that that would also give us a clockwise, or that would give us a clockwise rotation instead of a counterclockwise like A has. A has counterclockwise, B will have clockwise, as designated right here. You'll notice that I'll write VB prime, though, is equal to minus omega B times RB. And why am I doing that? Well, let me show you out here in this little sidebar. If you consider the writing down the vector expressions for these terms, you would have that the velocity VA prime vector-wise would be equal to omega crossed into R, where R is a vector that goes from A out to A prime. So that's a minus R sub AJ for that vector, and then the omega A is omega AK. I write that down as if it's positive, which means counterclockwise rotation. If it comes out to be omega A is negative, then it means the rotation is clockwise. So we have omega crossed into R is equal to 5 feet per second times the I unit vector. Well, when you do the K crossed into J, you get a negative I. That sign right there turns it into a positive I, and you'll be left with omega A RA times I equal 5 feet per second. Well, that's exactly what you have over here. Omega A RA equal to 5 feet per second. So you come out with omega A as a positive number, which means it is counterclockwise. Now let's do the same thing for VB prime. It's omega B K unit vector crossed into R sub BJ, because that vector is straight up, so it has a plus J, and that's got to be equal to 5 feet per second times I. K crossed into J gives me a negative sign, and I have a negative omega B RB right here equal to 5. So if you take a look at that, that's what I got right here, negative omega B RB equal to 5 feet per second. So when you calculate omega B out of this formula, you get a minus 7.5 radians per second. The minus sign indicates that it is a clockwise rotation. Now for the B part, we're going to look at the accelerations of these 2 points, A prime and B prime. The first thing we would notice, since this thing is moving through at a constant speed, there is no tangential acceleration for these points right here. So they're all going to be centripetal accelerations. Obviously, the one for A is going to point up, and the one for B is going to point down. But let's take a look at the equations. Typically, you'd have omega A squared times R sub A for the acceleration of A prime, or that A prime is 75 feet per second squared up, because it comes out to be a positive number right there. And then I've got a relationship here between A sub B prime and omega B squared R sub B with a negative sign. A sub B prime comes out to be a negative 37.5 feet per second squared, and that negative sign indicates that it's downward. Now, where did these equations come from? They come from right over here in this little sidebar. A sub A prime, since it doesn't have any tangential, is all, remember the expression in general is alpha crossed into R plus omega crossed into R. But my alpha is equal to 0 for these 2 cylinders. So A sub A prime then is equal to omega A crossed into omega A crossed into minus R sub A. In other words, crossed into this product right here. Well, I'm just going to repeat that, omega A R A I right there in that part, and then omega A K crossed into that gives me omega A squared R sub A. So the relationship between A sub A prime and omega A squared R sub A is that relationship right there. Now we do the same thing for B, and we have Alpha sub b is 0, so there is no alpha crossed into R term, but there is this omega crossed into R. And so when you perform these cross products here, you end up with minus omega b squared R sub b, and that's why I have a relationship here of minus omega b squared R sub b, so that when I calculate A sub b, I'm going to get a negative 37.5 feet per second squared. So when you do it out this way and write it like this, you get your directions automatically determined for you, and you don't have to go look at the figure and guess what directions are taking place. If you're worried about the fact that omega sub b is negative, notice it gets squared right here, so that goes away. So I do need that minus sign there, and it does come out in the works when you work out the vector equations.